We've successfully built the second stage of our model. Now let's see how well this linear model predicts recovery rates that are greater than 0. To test the model, we take the data frame with the test data and keep only the relevant independent variables. Those were determined by the features all list. Okay, then we remove the reference categories by dropping the variables with names contained in the feature reference categories list. Good job! Let's store the recovery rate predictions in the y-hat test LGD stage 2. To achieve that, we use the predict method as before. There are different ways to assess how well the model predicts actual values. Let's use a rather simplistic one, the correlation between actual and predicted values. There's a method in pandas to calculate correlations between two series. The actual values are in the data frame LGD targets stage 2 test. Let LGD target stage 2 test temp be equal to LGD target stage 2 test. We concatenate it with the predicted values contained in the array y-hat test LGD stage 2. Since the data frame LGD target stage 2 test has an index, if we simply concatenate the two using PD concat, they'd be matched by index. We've encountered this situation a few times already, and what we had to do is reset the index prior to concatenation. Let's reset its index, dropping it at the same time. Okay, now we concatenate the two objects. Once they are contained in the same data frame, we can apply the correlation method. The correlation between actual and predicted values is about 0.308. This is weak to moderate positive correlation in general, but satisfactory for an LGD model. In such cases, if the correlation was too high, we would have actually questioned our methodology. That said, let's assess our model in yet another way. We can look at the distribution of the differences between actual and predicted values, called residuals. If everything is okay, this distribution will be close to a normal distribution and will have a mean of 0. Let's plot the residuals using the distribution plot method from Seaborn we imported as SNS. Here, as an argument, we want the difference between the actual and predicted values. Okay, great. The distribution resembles a normal distribution, and most of the residuals are symmetrically distributed around 0. 0 is also the place where most of them are concentrated, so it seems to be a very good model methodologically. Let's save this model as well. Remember, we use the pickle package. We apply the dump method on the regression LGD stage 2 object containing the model. We'll save it in a file named lgdmodelstage2.sav. Don't forget to specify the write bytes mode here. Good. Now don't forget that this is only the second stage of the model. To reach the actual LGD model, we must combine the two stages. We'll do that in the next lecture. Thanks for watching.